Hey, what's up, viewer? Welcome back to this Nebulous live creation series. This is day 3, hour 2, and I still found myself a little unsure of how to proceed with the mesh generation of an active scan, due to the fact that it's requiring a recomputation of vertices anytime the object has to move, which would essentially be up to every frame. So the code has a solid shot of loading very quickly in the update loop like that, which is where using a shader graph would at least offload that vertex work onto the graphics card. However, I was trying to avoid using shaders to keep it prototypical. The other idea I had was to simply reveal signatures within the scan radius and not use a physical object. The visual feedback makes sense though. So for now, I'm going to do it in the update loop. And there's a good shot that I could use a coroutine or something to break up how often it has to do the work, but there's also the option of creating a job system. And that would at least use the multi-threading capacity and CPU cache potential of the processor. I'm curious how much of an effect it will have though, if I do it at the high level like this. So I'm going to continue formulating the rings, and essentially every frame they have to adjust their radii, and then the new rings have to be passed into the mesh rebuilder, and they have to be assigned to the scan forms mesh filter as a mesh. Or I might be able to just assign them and not rebuild the mesh, which would be more efficient for doing what I'm trying to do here. And I'm going to have to see how the efficiency works. It's not a good long-term solution because multiple scans will take it pretty hard. If it starts to break, I can regress it to not using this object and just use the radius. So for some kind of visual effect, I'm curious how it will look. Alright, so I'm still going to have to kind of microformulate here what I'm doing. We're assigning the radius every time, and that radius is changing from a start point to an end point. And the rest of the values on the rings will stay the same. So all the other proportions will stay the same, it will simply expand the ring. So we're scaling this up. So it needs a start float and an end float. Alright, so what I'm considering here is essentially the I think I'm thinking the cross product of the angle as long as it's on the y plane. That is essentially the direction of radius. That vector times radius is the endpoint, and then the origin of the ring is the beginning point. The other option is to say the angle is equal to essentially half of the midpoint between the starting arc and the ending arc. So like the difference, like half of their difference minus the larger value. And I suppose I do have that data in the form of active scanning radius, or excuse me, active scanning angle. So I think this is just the arc, this isn't the vertex positions. You can also assume that perhaps forward is 0 degrees and just rotate forward by the angle. I think the other idea was going to work though. But for that we wind up needing the min-max. Wind up needing the min-max from the min-max slider. So not only do we have these active scanning values, but we're going to need public float, active scanning angle max, or perhaps upper and lower. And they have to get assigned anytime the arc changes. Also just down here at the bottom. Alright, so this is going to give us access to those upper and lower values anytime they change. In which case we can access them on update. which, okay, so how was I describing this? We had basically the top angle minus the bottom angle, or was, so upper minus lower, divided by 2, all of which subtracts from upper, so upper minus half of upper minus lower. And this is going to effectively be a rotation angle around the starting vector, which I believe my mesh formulator assumes is so it's like this angle is using vector theta forward. Okay, so we will use assume that we will be starting at vector theta forward as 0 degrees, which I comment this out and just double check here. Alright, so if let's see, which direction is forward here? It's going this way. So does that mean forward is effectively the starting angle? It looks like it is exactly the starting angle. So we can assume that we're degrees beyond the forward vector. Therefore, we can assume that this angle yielded from this math here is how much we need to rotate the forward vector by to get the directional vector. Multiply that by the radius to get the maximum position that we need to lerp towards from the center. It also helps to yield the proper distance that has to get divided by frequency to determine what the t value is going to be. However, that will shift our radius every frame for each ring separately. And we will also rebuild the mesh values every frame. And we'll see how much that takes the efficiency. So I'm just going to write it very inefficiently here, but we effectively have this is more or less a rotation degree, and upper lower is player data dot, what was it, high autocomplete second active scanning angle upper. And it's essentially the same thing here, just copy it like this and then say lower. And that's our values that the player has deemed in real time to match the arc of their ring, the radial scan ring. And this will give us the rotation that we have to more or less say vector 3. If we call this rotation, probably just call it rotation vector. And this equals a quaternion dot angle axis. And the rotation degree is the rotation degree that we just got from the algorithm. And the axis is our vector 3 dot forward axis. And we have to multiply this. I guess what do we... Oh no, we're angling... That would mean that we're angling around the up axis because we are rotating. Okay, so this is effectively what we're actually doing. We're taking the forward vector and we are twisting it on its y-axis, the up axis, by a rotation degree. That's going to turn it only... It's going to make sure that the only values that change are x and z values and not y values. And it's just going to point the vector by the midpoint of the chosen arc angle. Which is what we need to multiply by the player data dot active scanning radius. Yes, active scanning radius. And to multiply that by the rotation vector that we just created. And that is going to be the endpoint of our lerp, of our radial lerp value. And it's also asking for a, it's only asking for a float here. So I might have to change this a little bit. This is saying there's no position. Transform that position. So this is a little weird. It's asking for floats, but it's taking in vector 3s. So I'm curious if that's actually going to work. And here it needs the t value, so we have to actually come up here and we have to think about what the t value is. So t is actually, or float t equals, I guess, just call it iterator. So the iterator is player data active scanning radius and the idea is divided by the active scanning frequency. But that's going to really change how the balance works for the frequency value. But it might slow down the might help for determining which, or it might actually help also determine how many times it has to run total, to a certain extent. At this stage, though, we've got, at this point, it's only going to have like 2 steps, or at the most 10 steps. So it would, the other thing we would be able to do would be just use time, essentially use time as an iterator. Which I don't know if we can actually do that or not. I guess this would require an initialization. You would want to say this. I would have to go like this. And let's just initialize it. And yank out the type. Is add time delta time. Which only exists for the lifetime of the object. And more or less, t then becomes the iterator. Now it's angry that I am giving it vector 3s and not floats. So the step I've got to do here is I actually have to come up with float. I suppose I don't actually need a I might just be able to calculate the change in radius by just using the radius value. Which means the float here would be, I don't even know if I need this rotation vector. It would just be the radius. And we assume the radius is 0. Because this is assuming the ring is and the idea here would be that it will lerp the radius smoothly from 0 to the scanning radius, and it's just going to scan, or it's just going to expand the ring by whatever angle the player has defined. This might be much simpler than I originally made it out to be. And then once the rings have been redefined, the mesh does have to get rebuilt. So effectively, I'm just going to say mesh, and then mesh equals I suppose I could just put it right here. This thing's shared mesh. This is the mesh I'm referring to. And that will have to be given new values. So for instance, set vertices, I think you can just take in some values. And the same exact mesh pattern can actually just change its vertex position. So maybe it will be alright for now. doing it like this. And those vertices would need to come from the mesh formulator. But I can run the ring measurements, but build I suppose the way I'm feeling it would be add ring form. And then mesh formulator build rings with ring measurements, which we have redefined ourselves, sorry. Not ourselves, that's not correct. And I maybe have too many here. Okay, so the mesh formulator then needs to essentially return its list of vertices. But it's not an instance like that, so instead you have to go like this. And I'm just going to do clear collections because it's going to be a little cheaper than initializing every time. And then the final step is to say mesh formulator dot what vertices dot to array, and the meshes of vertices will now actually change. The idea would be that this has a finite lifetime, so like eventually this update loop will get removed from the cycle, but the problem will occur if I have like 18 of these flying around. Not sure. However, this should, upon hitting the update loop, it's going to expand the mesh. So this is like this is an instantiate destroy system. So we'll see how quickly this actually breaks things. And I actually want this out here. Alright, so now since this is a prefab, we will create a new object. We'll just call this active player scan, because it's probably not bad to differentiate. Alright, so it's going to need a mesh filter, as long as I can type it correctly, of course. It's going to need a mesh renderer. It's going to need the component we just created. I believe it was this one. No, it's not correct. Active scan form. And active scan form is going to be responsible for assigning the mesh. We still need to provide the material. Quickly, they'll plug in the player data, and it's not going to render properly until we have a material plugged in. So we're just going to have to bite the bullet and create a shader graph for this thing anyway. We can put it under player scanning. And we will go to create shader graph, HDRP, and we'll do a lit shader graph. So it's a lit active scan, active player scan. I'll have to pull up the shader graph. And it'll just be base gray according to this. We can take our active player scan and drag the material for the active player scan onto this material slot. And now if we start to define the mesh, it will not complain that there is no material. And then we can mess with the colors depending on how it looks. And it's designed to rebuild them on update, but it's going to be grabbing the scanner values. Alright, so let's go with 4 rings. And that will be a way to... that's actually kind of goes against what we were just doing. Okay, for simplicity's sake, I'm going to make it 2 rings. And one ring is at like negative 0.1. The other ring is at 0.1. And something I've forgotten is that the collider for this object will have to get assigned as well whenever the mesh changes. The radius is set by the player. These are relevant for this particular ring. Points on the ring. I don't think I had a very high number for that one. If I lower this though, we'll have a lot less work to do. So like how about like 5? And then the angles are chosen by the player slider as well. So the only 2 values left are determined by the player slider. Because the algorithm works off the so it's working off the real-time value. Excuse me. If it's working off the real-time value, there's potential for the player to make a new selection that can scan and change the angle, which is a good point. We do not want that actually changing the trajectory of the live scan. I apologize for the silence. Okay, so I was losing track of one thing here. Whenever I generate the mesh, this ring needs to have its start, or the ring measurements have to have their rings start and end angle values matched to whichever values the player has selected. At the time of this object instantiating is essentially the way it works, which means that this wouldn't work 100% if it got transitioned into object pooling because it isn't properly initializing its rings. However, if we assume it's getting instantiated, then what we can assume is players made a choice about the active scanning angle before they were able to spawn this active scan form. So for this active scan form to spawn, they had to have an angle. So we're going to, it's the only way it can get instantiated, so we're assuming it's instantiated properly. And before we run this part, we have to run the rings through a loop that will take the active selections of the slider, which was actually what we were doing here, I think. And we will set up the rings with that data before we do the update data, which is more interested in lerping the radius. And that will actually make sure that the rings get their angles set properly for the update loop. And then it will just come down to the radius scaling through the lerp. And it'll depend on how fast the whole process is updating. If it's too fast, or if it tanks the whole thing, there's things we can do to fix it, but I'm curious in just like writing the code that is most verbose. Okay, so we're just gonna have to have a for loop here. So we got a for loop, and it's for all of our rings. And we have to do the same thing here, ring measurements, and for each ring, we are changing the ring's start angle and the ring's end angle to values from the player data, which are the active scanning angle lower and the player data active scanning angle upper. And this tells each ring what the arc is, which builds the ring with the proper arc values. And then a ring form is added to the mesh formulator data structures, and then they are built onto the mesh component, which we actually cache for later, which we change the mesh values only. Kind of doing the same thing, we just clear the collections, assign a new array to it, and yeah, we basically just generate a new array from the mesh formulator list, and that gets converted into the array that gets set to the mesh, and that keeps it from generating a new mesh every time using our build mesh, which generates a mesh and returns it. So instead we are only assigning to a mesh, not generating one every single frame, and this stuff just works off of this list. And the list doesn't have to allocate extra because it winds up being the same amount of vertices every time, basically. They're just in different places because of the radius. And then it sequences the ring together for the proper mesh values. And the indices stay the same, and the normals stay the same, and UV stay the same. So I think just doing this will actually achieve the effect I'm looking for, as long as one other thing happens, which is we basically have to see if iterator has completed. Which essentially means if the I'm gonna have to play around with a lot of these values, like the iterators and stuff, but okay, so basically if the so let's just say, okay, so if ring measurements.I, or actually at 0, if its radius is equivalent to player data dot active scanning radius, and that effectively means, I spelled it wrong, pal your data. I spelled active scanning wrong also. But essentially active scanning radius, that means it's lived up to its, that means that it actually lived up to its, or it essentially means its radius has expired. Its range has expired. So in this event, we can make sure that it winds up scheduling itself for destruction. And that will remove this update from the system. So we'll basically just have to say destroy. Okay, so we basically destroy. This instance of active scan form. And I'm not sure if that actually means, and to be more clear, we should say game object is really what we're trying to destroy here. Alright, I'm just gonna give this a shot. I have no clue how this is gonna work. So the angles and the radius get set manually. Rotation angles and axis don't matter for these rings. The material setup. The prefab is created. So let's delete the object. We have to make sure that the spawner has access to the, I guess it's not the spawner. I was under the impression there was something. I guess not. Something has to spawn. Oh, okay. So something has to spawn the actual or something has to instantiate the object, and that's going to be essentially whenever we click the scan button. So that was under our active scanning elements. At the bottom we had our button, and essentially the yeah, I mean, this just actually drained the economy. Which is why we went through such painstaking effort to deactivate the button here and there. And we've got... Now what we have to do is instantiate a waveform. And we are instantiating an active player scan. And since we have it set up as a prefab, we just say active player scan. And we've now created an object scan, and we really want the object's initial radius to be I don't really care if it's a parent, so instead all we really need to do is assign the game object hold on. Okay, so I need to grab the what was it called? Okay, so player data dot active scanning radius object. This thing's position is where we are instantiating this scanning object, and we need to just use the identity turning. And that will not interfere with how the object is set up to instantiate, which will make sure that it does its transformations properly around the act. Oh, we didn't actually mess around with that, did we? But we did have some. There is some angular math done to the rings if the player changes the slider. So we don't need to do any extracurricular rotations here. And this will now create a scan in the update loop with the mesh values assigned, with the shader assigned, and it'll spend the economy, and the button only activates when it's affordable. So let's see what happens. Make sure I plug in the prefab. And let me double check the prefab has everything it's supposed to have. Use the player data. Oh, it's not actually taking the player data object. So I can't just plug in the player data. Player data will have to come from just have to do this like this. And we now have the, oops, I spelled it wrong, but we have the proper component on instantiation. And then it's still going to, it's not going to be so bad because there's only so many objects in our top tier. There's only like 8 or 9 or whatever. So this means that on instantiation it should in fact plug in that proper value. Bravo. 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 Fucking bravo. My god, I am sorry. I'm clapping my hands. I swear to God, it's clapping my hands. You might be surprised sometimes, but dang. Like, okay. That is like almost exceeding my expectations. Holy cow, that's okay, that's awesome. That's awesome. So that's like almost exactly what I wanted, basically. Okay, so that wound up being even cooler than I thought it was gonna be. I'm sorry, that really got me. That really got me. I was not anticipating it to go like that. What can I tell you? But dang, okay, so that's pretty cool. So now we can see where like scaling the frequency is going to change how quickly the waveform actually jumps out and traverses across the screen, because the frequency can tweak the iterator that we use in the lerp value, which is what achieves the spatial travel of the wave. And it didn't, well, I guess I should probably test a little bit if it's how efficient it is with it being an updated value, but it worked. It turned off at the right point. I'm sorry, that really got me. I was like, I wasn't sure if I was gonna get it working or not, and then it like freaking worked. That was pretty cool. It's always special when it happens. Making this stuff. Okay, so what was I testing here? I was gonna test if it tanks the frame rates. And oh. Like that, it's too expensive. I can't do it. I guess it doesn't matter. I could probably still launch it. Alright, let's see if it tanks the frame rates. It didn't even, I didn't even see it. It tanked a smidgen for a second there. But what about adding triangles to the scene? It looks like it there was like 100 verts got added pretty consistently. But the milliseconds doesn't really go down. I don't see any other performance indicators going down using it. The set pass calls goes up by 3. Which is already running 70, apparently. The other thing is when the wave goes out, it would be cool to turn off the ring, I suppose. But there's a few things we could do with this. Trying to micro adjust it to just beat the economy. It's kind of weird. Oh, it's because I spent some. I don't know about that. All right, let's see here. So it says my total economy is negative. It almost looks like it's disconnected from the displayed economy is not shifting anymore by... Oh, is it because my frequency is at 0? Maybe. Okay. And this is going to make it go up as well. Alright, well, before I cut this video, I'm going to try and do a large scan and see how that goes. Max radius, turn up the frequency just enough, and then zoom out the camera just a little bit. And let's see how this looks. Oh, it didn't work. Or I did that thing where I broke the connection, so let me try it one more time here. Ah, see, that didn't work very good because it only had 3 points in the ring, but it's on the right track. You'll be able to scan with some visual feedback. Alright. So I suppose that wasn't so bad. That was like, most of that video was like, I felt like I was really going kind of slow, droning on, trying to really figure it out, but that wound up working. It needs some tweaking, but it's actually basically an effect. So the only thing left is like putting a collider on it so that it'll collide with stuff in space and discover for the player. So I'm going to start figuring that out in the next hour. See you later.